Welcome to the viewers. Now we discuss matrix multiplication. Now, how to find the multiplication of a matrix? The only condition is the number of column of any pre-matrix must be equal to the number of rows of post matrix. Now what happens there? If A be any matrix of order 2 by 3, that means number of row is, here it is number of columns and number of rows. Number of rows is 2 and number of columns is 3, and B be another matrix of order 3 by 2, that means number of rows of A is 2 and number of columns of A is 3, and here number of row is 3. So number of column of the first matrix, that 3, is equal to the number of row of the second matrix is 3. So these two are equal. So AB is conformable for matrix multiplication. AB conform for matrix multiplication. An order of AB is here 3 by 2 and here 2, so it will be 2 by 2. And if we take with the help of example, we find the product of two matrices like this. If we take A matrix of the order 2 by 3 like this, 1 minus 1 0 2 0 minus 1, and B be another matrix 0 1 1 3 7 0, and we can say if we take this product, it is a matrix of the order 2 by 3, and if we take B, this is a matrix, it will also be 2 by 3. But here if we consider these two matrices, product is not possible because number of row is 3, 2, and number of column is 3, but here number of row, that will be 2 and number of column is 3, so number of column not equals to number of rows, so its product is not possible. But if we take its transpose of the matrix, and elementary we got the idea about transpose of the matrix, we getting this result, number of rows like this 0 3 first row first column, 1 7 and 1 0. If we take, it will be 2 3, and then if we watch, this product is possible. So AB matrix, that is matrix multiplication of AB is impossible, but matrix multiplication of AB transpose is still possible. 0 1 1 and this result. Therefore AB transpose equals to AB transpose is possible. This is multiplication of A and B transpose. Therefore, but here transpose is a concept where row change into the column. This is called transpose of a matrix. Now AB transpose equals to, we are writing this 1 minus 1 0 2 0 minus 1 and another matrix 0 3 1 7 1 0, and if we take the product of the matrix and AB transpose is of order, its order will be, it is 2 by 3, it is 3 by 2, so its order will be 2 by 2 if we take the product. Then how to make the product? First row, first column, position of the element multiply with the same positional element, that is 1 into 0 plus minus 1 into 7 plus 1 into 0 plus minus 1 into 1 and 0 into 1. First row, first column, 1 1 position. First row, second column, 1 into 3 minus 1 into 7 plus 0 into 0. Second row, first column, 2 into 0 plus 0 into 1 minus 1 into 1. Second row, second column, 2 into 3 plus 0 into 7 plus minus 1 into 0. Finally, we get the result. If we take the matrix 0, it will be minus 1. So result will be minus 1. Here it is 3 and minus 7. Here it is 0 minus 1 and here it is two components are 0, that will be 6. So final result will be minus 1 minus 4 and minus 1, it will be 6, and if we watch, its order must be 2 by 2. So in this way we find matrix multiplication. But here important things is noticeable here. That's a transpose of a matrix, that is row change to the column. Here this transpose, that is first row, that will change to first column and second row changing to second column. And in cases of the transpose of a matrix, if we discuss this transpose of the transpose of a matrix, also the same element, same matrix. Now we consider here also this property today. Now here B be the matrix we call 0 1 1 3 7 0 of the order 2 by 3. Therefore B transpose, that will be must be the order of 3 by 2. So first row change to first column and 3 7 0, it must be order of 3 by 2. Now if we consider transpose of the transpose, that is another change. So also first column changes to row. So first column change to first row, it is 0 1 0 3 here, and second column change to second row, that is 1 7. Third column change to third row, that is 1 0. So it must be order of 2 by 3, and we get the same matrix as the earlier one, and that is the matrix of B. So transpose of the transpose of any matrix, will be the same matrix. This is also a property of transpose of a matrix. If we taking notation as BT, or some books may be notation as dash, whatever maybe it is, but both have the same meaning. And now we consider the identity of a matrix, that is given by I. Identity of a matrix given by I. This I is equal to, if we consider 2 by 2 matrix, order of 2 by 2, this is a square matrix, 1 0 0 1. Similarly for 3 by 3 order matrix, 1 0 0 0 1 0 and 0 0 1. In this way, for I n by n order matrix, we can find 1 0 0 dot 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 0 1 0 dot 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 0 dot 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 0 up to this is 1. So it is a row and column, that is n by n. Both are the square matrix order, 3 by 3, 4 by 4, whatever may be, we get in this way. Now we end our discussion today to give some of the idea about product of matrix, transposition of matrix and identity matrix. Now we end our discussion, and if you like this video, like it, share it, and don't forget to subscribe the channel. Thanks for watching.